taking a look at the example side, questions you had. Let's start with example 2. Any questions on example 2? Go ahead. Julia?
9.
Number 9. Sounds like a lot of number 9s. And hey, this is one that we didn't go through yesterday on how to factor it. Okay? And when we look at it, hopefully you look at the bottom and you think difference of two perfect squares. Right? Perfect square and different sign. Let me go ahead and copy that down so we give ourselves some room here. All right, so our x squared minus 6xy plus 5y squared over x squared minus y squared. Okay. Thank you. So, looking at this, difference of two perfect squares on the bottom. So the square root of x squared is? X square root of y squared? Y. Okay. So hopefully we recognize that. All right. This up here, that's tough though. You get these x's and y's. Please note at the front though, you got a perfect square, and at the back you have a y squared. Okay. Anytime you have that, if you take the square root of this and the square root of this, and you're able to multiply them and get this middle term right here in terms of your variables. So half of that and half of that, that's attached in the middle. Really, we would think of this. I know there's other mathematical ways to think about it using substitution, but we're going to go over here to imagination land. All right? We love visiting imagination land. Which really means you're actually just thinking substitution, but that's okay. We'll get to that another time. So we get x squared minus 6 plus 5. 6x, excuse me, plus 5. Okay? And if we solve that, that gives us, or if we factor that, that gives us x minus 1. Good, x minus 1, x minus 5. Now, if we put the y back on here, a y squared at the end, that means that has to have a y and that has to have a y. Okay? And how that affects our problem then, when we're solving this, is if I go x times x, I get x squared, and then I go x times negative 5y, that's negative 5xy, and then negative y times x is negative xy, and that gives us a negative 6xy, and our plus 5y squared. Okay, so that is the factored form of that. X minus y, x minus 5y. All right, you're going to see another one of those today. So x minus y and x minus 5y. All right, that then allows us to cancel here and here. It leaves us with
x minus 5y over x plus y.
Good. All right. And remember we stated, we were talking about it when we were correcting, that in this case, when you're looking at this, you want to find your restrictions. You're going to set this part equal to 0. So x plus y cannot equal 0. And when you solve that, you subtract y on both sides. You get x cannot equal negative y. So that's one restriction. Then you do the same thing over here, which is going to give you a positive y, right? X minus y cannot equal 0. You solve that, you add y. Okay, you keep pushing my desk, man. So x cannot equal y. So those are our restrictions. So really, we didn't do this yesterday, but you should get in the habit today of writing your answer. And then putting your restrictions afterwards, saying x cannot equal y, or negative y, and x cannot equal y, or x cannot equal plus minus y, if you want to think of it that way. Very good question. Other questions? Example 2. How about example 3? Sophie? Number 12. Lucky number 12. All right. Go ahead and write it down here. Or actually, just keep it there and we'll zoom in. Okay, so starting out by factoring, this part right here, what we could take out is an x. So we get x plus 6. Here, can we factor that? Two things that multiply to make negative 8 and add to 2.
4 and negative 2.
Good. Plus 4 and minus 2. All right, so we're good there. We're good there. This is already done. I'm just going to put parentheses there. And how about this one?
Pull out a 3.
Yeah, you can pull out a 3. So I'm going to do that on the paper here. So we're going to have 3 times x squared plus 2x minus 8. And that's where some people forget. And you'll notice this x squared plus 2x minus 8, if you can still see up here, that's the same quadratic. So really, if we wouldn't have factored this, we could have just canceled those quadratic pieces out. Okay? But since I already factored, I'm going to go ahead and write it like that. And then I'm just going to cancel them anyway. So.
Boom.
Yeah. Kick them out, man. So that gives us x times x plus 6. The x plus 6s are going to cancel.
Oh my goodness.
So our numerator is just,
X.
denominator is just 3.
You're off the screen. Alright.
Okay? All right. Hey, and once again, our restrictions. So if we're writing this like I just said to write it, x over 3, restrictions, x cannot equal negative 6, negative 4, and positive 2. All right. Okay. Other questions? Example 3. Okay. Overall, how'd you guys do? 1 to 5. 5 being the best, 1 being the worst. Okay. Okay. Hey, let's take a look at today's stuff. Go ahead and turn your paper over. Okay, our assignment today is going to be 17 through 32. I know. That was the size of excitement. Good. Yeah, that's right. Okay, so number 17, let's take a look at that one. Or number 19, actually. Number 19 and 20, when you look at that, that looks like a joyous set of problems. Let's just go on to 19 and check that one out first, okay? Okay, so write it on a clean sheet of paper, maybe even in your notes. There we go. The joy of what we're going to be calling factor by grouping.
Oh,
In fact, other people call it that as well.
dude.
I know. Pretty crazy.
Yes.
Hey, I think we touched on factor by grouping a little earlier in the year. You remember that?
Probably not.
It was very brief. Okay? But anytime you have 4 terms and you're starting to look at it and you're like, wow, that looks tough. Okay? If you can make groupings, okay, hence the title factor by grouping, if you can make groupings that then you can pull an expression out of, that makes it a lot easier. So I'm gonna just start trying to factor this top one. I'm gonna actually rewrite it down here just so I have a little more room, and I'll put my answer up there. But okay. So if I'm going to do factor by grouping, I'm going to start by trying to make some groupings. I'm going to group this here and this here. And when I group those, I look at just that quantity. What can I take out of that?
X.
An x. And if I take that x out, what am I left with?
2x minus y.
Okay, 2x minus y. And you'll notice over here I have 2x plus y. But I have this subtraction sign in between. So what could I pull out of this thing? That set right there.
Nothing.
Yeah, there's nothing that looks very evident, but how could I make this? Okay, let's do this.
Subtract them.
So hold on. Let me erase this. And then rather than having that be our group, let me write the negative out here. Okay? And rather than putting the parenthesis here, let's go ahead and include that negative. What's here now?
Addition sign. Multiplication. I lied.
It's not multiplication.
It is addition.
It's a plus. Okay? So what are we pulling out of there? -1. So now if we pull out a -1, I have a -1. Okay, and our plus can come down. It's going to get rid of itself here in a minute. Right? The plus and minus will just become minus. When I pull out that -1, what am I left with here? 2x. And what am I left with here?
Minus y.
Minus y. Okay? And notice these quantities, this set and this set, they're identical. Okay? This plus minus just becomes a minus. So this whole piece factors to x times 2x minus 1, or 2x minus y, minus the quantity 2x minus y. Okay, and I'm going to keep that 1 there. How many are with me? Okay, so now from here, what's the greatest common factor of this set and this set?
2x minus y.
2x minus y. So 2x minus y, if I factor that out of both of those, what if I divide by 2x minus y here? That's what factoring is. What am I left with?
X minus 1.
I'm left with x here. If I take 2x minus y out of this, what am I left with? -1. So this whole thing up here factors to that. That's factor by grouping. Now, no one said it's easy, right? Like if we read that thing above the board, if it were easy, everyone would do it and be good at it. It's not easy, but you can do it. Okay? So let's give it a go. We're gonna change this one right here. Okay, so I'm gonna go back up. We had 2x minus y times x minus 1. Hey, this one's easy. I'll do this one for you. There you go. Okay? In fact, I'm so generous, I'm going to do that one too. All right? You guys have to try this one. Everyone try to factor by grouping on that one. Your best you can. Ready, go. Guys, when we go through this, okay, our groups, I'm going to go x squared plus xy plus x plus y. Okay? And here are the groupings that I saw, those that I worked with group. That was good. And I saw most of you pulled out that x, and so you said x times x plus y. And then you're like, hey, that's x plus y. Okay? And so we don't have to do anything to that. This is where some of you are getting stuck, though. Okay? So in order to explain this a little better, I'm going to try to go through this problem right here. Let's think back to factoring 4x plus 8. Okay? Guys, 4x plus 8, what's the common factor?
4.
4. And it's 4 because 8 is actually 4 times 2, right?
Yeah.
Everyone agree with that?
Yeah.
So we have 4x plus 4 times 2. When I pull that 4 out, I'm actually dividing by 4. The 4 comes out here. 4x divided by 4 is?
4x.
X. And 4 times 2 divided by 4 is? 2. Okay? The piece you pull out just goes out here. You're dividing by it. What's remaining, the 4 or the x and the 2, stays in here. Okay, so the piece I pull out of this is x plus y. When I divide this thing by x plus y, I'm left with x. And when I divide this by x plus y, I'm left with
1.
positive 1, the one out here. Okay? It's the same thing as the 4 times x plus 2. It's just the 4 looks a lot weirder, right? Or more weird. Okay?